Okay, guys, so honors chem, sorry that got interrupted. We're going to do some more of these diagrams. And I think if I remember correctly, we were just working on helium. So let's look at helium and let's look at the diagram here. So if I look at the place we were on the hotel analogy, we had put in both an upspin and a downspin arrow for the two electrons in helium. So we have 1s. This is our lowest state. Remember, we're going to use the Aufbau principle, so we can only do things in the lowest energy orbital that is open, and that's what we have. So we have everything in the 1s. This, remember, is the energy level, or our n number. This is our type of orbital, or our L number. And then because we have two electrons in here, we're going to put 2. This gives us the number of electrons. So if I have an s orbital, that means L is equal to 0. Okay? So those are my quantum numbers. So let's fill this in. So for helium, my electron configuration would be 2s, or sorry, not 2s. Oh my gosh, I'm losing my mind. Sorry. It would be 1s because we are in the first energy level. We are in an s orbital, but we've got 2 electrons. Okay? So our orbital diagram would be 1s, and in that orbital we would have both an upspin and a downspin electron. Our dot, because these are this is our outermost orbital, and we have 2 electrons, our dot here would be helium's symbol with 2 dots showing the 2 electrons in that outer. Okay, so that last electron that we just put in here, it was in the first energy level, right here, first energy level. It was in an s orbital, so my L number is 0. My M number is also 0, but it was a downspin electron, so my spin number is -1/2. Okay, let's go on to lithium. Okay, so if I look at lithium, I now have 3 electrons. Okay, so let's look at our hotel analogy. So if I have 3 electrons, this 1s is already full. So the next energy level up is my 2s. I'm going to put the upspin in here. So here's my energy level, and here's my type of orbital, and my type of spin. Now, notice this is 2s, so this is my second energy level. Let's look at the periodic table. Lo and behold, isn't this in the second period showing that I'm in the second energy level? Okay, so let's look at that really quick. Let's put this in here. So we said we were in the 2s. Let's change our color here. We were showing that we had the 1s, 2, already full, and then we had to put that third electron in the 2s, and we just put in 1 electron. So our orbital diagram, we're going to have 1s, and we're going to have both the up and down spin for those first 2 electrons. And then the third electron that we just put in, we put it in the 2s, and we put it in the up spin. Okay? Now, for our quantum numbers, let's do quantum numbers first before we do our dot. That last electron we put in was in the second energy level. It was in an s orbital. So an s orbital, the L number is 0. The M number is also 0 because there's only one orientation. And it was an upspin, so our electron will be +1/2. Now, The thing is, valence electrons are only the electrons with the highest energy level. So if I look at my highest energy level, I am only going to look at things that have 2 on them. Okay? So when I look at the things that only have 2 on them, 1 is on the inside. Now I have the 2s, which is the outermost level. I only have 1 electron. So my dot picture for lithium is just going to be lithium with 1 dot. Okay? Let's do beryllium. So if I look at beryllium, I now have 4 electrons. Okay, let's look in our hotel. Where is that 4th electron going to be? My lowest energy level that's still open is still 2s. So I'm going to put it as a down spin electron. So I now have the 1s and the 2s totally full. Okay, so my numbers, 1s, 2s, and now I have 2 electrons there. So I'm going to have 1s, both the up and down spin. I'm going to have the 2s, both the up and down spin. So on my 2 level electrons, I have 2 of them now. So my dot picture for beryllium, I'm going to show beryllium. And I'm going to put them on the same side because they are in the same orbital. Okay, so my quantum numbers, I have my 2 for my second energy level. I have my S, so S means my L is 0, which means my M is also 0. And it's a down spin, so it's a -1/2. Okay, let's now look at boron. Okay, so if I look at boron, I now have 5 electrons. Notice I am now in the P block. Okay, so let's look at the hotel. Lo and behold, my S's are full, but my P block is my next orbital. Now, really, in reality, I can fill in any one of these orbitals. They're all the same level. We're just going to go from left to right. Now, remember, when we have a P orbital, that means our L number is 1. And remember, our M sub L numbers, or our M numbers, can go from -L to +L. So we're going to have -1, 0, and +1. So I'm going to label this. This is going to be my, actually, let's do it the other way. This is going to be my -1 orbital. This is going to be my 0 orbital. And this is going to be my +1 orbital. Or if you want to think about it of X, Y, and Z, this is going to be my PX, my PY, and my PZ orbital. Okay? So those are the orientations that we have. Now we really are just going to fill it in from left to right. Oh my. What's this all about? Okay, so we're going to have 2p now. Okay, and our first orbital is -1. So let's look at that. So I now have, let's change the color here. I now have 1s2, 2s2, 2p1. So my orbital, 1s, up and down, 2s, up and down, and 2p. Now remember, there are 3 orbitals in 2p. There's the -1 orbital, the 0 orbital, and the +1 orbital. We put an up arrow in there. Okay? So Once again, we are going to grab only the electrons that have the highest n quantum number. Our highest n quantum number is anything with a 2. Okay, so we're going to grab these. We've got 3 of those electrons. So when we look at this, we are going to have beryllium with 3 electrons. Now we have these 2 right here in the same orbital, so we're going to put them on the same side. But this one is in a different orbital, so we're going to put this one on top, showing that that one is in a different orbital and it's by itself. Okay, so here we go. Our last electron was a 2. It was in a p orbital. Remember, if we have a p orbital, L is 1. Okay, so L is 1. We put it in the -1 orbital, and it was an up spin. So it was a positive. Okay, so let's go and put in carbon. So if I look at carbon, I now have 6 electrons. So let's see where in the hotel analogy where I need to put in this next electron. Now, all of these orbitals right here are the same energy. And remember Hund's rule. Hund's rule means that the electrons are going to go into the orbitals as singles until they have to double up. So this electron is going to go into this orbital so that it doesn't have to double up. And it's going to have the same spin. So we're going to put in all the up spins first in all the orbitals before we start doubling up. So we're at 2p2, and we're in the middle orbital. We're in the 0 orbital. Okay, so let's put that in. So I still have, let's change the color here again. I still have 1s2. I still have 2s2. Now I have 2p2 electrons. Okay, so when I look at this, I have 1s both up and down. I have 2s both up and down, and 2p up and up. Remember, this is my 0 orbital. Okay, now my dot picture, I'm going to grab everything that has a 2 in front of it. I now have 4 electrons, 2 right here that are in the same orbital, 2 right here that are in different orbitals. So let's do this. I've got the 2 that are in the same orbital. I have this one right here that is in the single orbital, and then I have this last one that's in this single orbital. Okay, so I'm going to show them in different orbitals away from each other. Okay, my quantum number, I have a 2. It's a p orbital, so my value is 1. It's the middle orbital. So remember, this middle orbital is my 0 orbital, and it still is an up spin. So this is positive 1/2. Okay, let's go on to nitrogen. So if I go on to nitrogen, you'll notice I keep adding 1 more electron. So let's go here. 1 more electron. We're going to obey Hund's rule again. So we're going to go into the last unoccupied orbital of that energy level, and we're going to go into the positive 1 orbital, or the pz orbital. We're still on the second energy level. So when I look at this, I now have 1s2, 2s2, and 2p3. So 1s up and down, 2s up and down, 2p up, up, up. Okay, so my dot picture for nitrogen is going to look like this. I'm going to have the 2 orbitals, or the 2 electrons in the s orbital. I'm going to have a single orbital in the negative, or electron in the -1, a single one in the 0, and a single in the positive 1 orbital. Okay, that needs to stay there. We'll erase this. Okay, so my quantum numbers, it was a 2, it was a p orbital, it was the positive 1 orbital, and it was a positive spin electron. Okay, so let's look at oxygen. So if I look at oxygen, I'm going to grab yet another electron. So let's see where on the hotel that next electron goes. Okay, all my rooms or all my orbitals at this level are all already occupied. But remember, each orbital can have 2 electrons. So I'm going to start doubling up. So this is going to be a downspin electron right here. And I'm going to put it in that -1 orbital. So here we go. So I now have 1s2, 2s2, 2p4. I should probably change colors, shall we? 1s up and down, 2s both up and down, 2p up, 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 and that fourth one is going to go down. Okay, so now I have oxygen right here with the 2 here. I have 2 together here, and I'm going to put those on top. And then these are singles, so single and single. Okay, my quantum number, it's still the second energy level. It's a p orbital, so it's 1. It's in the -1 position or the -1 orientation, and it was a downspin. So there are my quantum numbers there. All right, let's do fluorine. So fluorine, I have 9 electrons. Let's see where that 9th electron needs to go. Okay, so I'm going to put a downspin in this middle orbital. So I now have 1s2, 2s2, 2p, 1, 2, 3, 4, 5. Okay, so here we go. Let's switch colors. 1s2, 2s2, 2p5. So 1s up and down, 2s up and down, 2p, I have 3 orbitals, up, 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 down, and down. Okay, so my dot picture for fluorine, I have 2 in my s orbital, I have 2 in my -1 orbital, I have 2 in my 0 orbital, and I have 1 in my +1 orbital. Okay, that last electron that I put in was a 2. It was in a p orbital. It was in the 0 orbital, and it was a negative spin. Okay, so neon. Let's have a look at neon. So if I look at neon, I am going to grab 10 electrons. Okay, so let's look at the hotel and see where I need to put that 10th electron. So that 10th electron is going to go right here. Okay, so here we go. We have 1, let's change color here. Once again, I have 1s2, 2s2, 2p6. So 1s up and down, 2s up and down, 2p up, 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 and down, down, down. So my dot picture, I'm going to put it over here. I'm going to have 2 on the side, 2 on top, 2 on the left side, and 2 on the bottom. Okay, so there's going to be 8 around there. Octet. We're going to find out about the octet rule in a little bit. So, second energy level, p orbital, it was in the +1 orbital, and it was a -1/2. All right, let's look at sodium. Okay, so if I look at sodium, I am now on a third level. So we are now hopefully going to be in the third energy level. So we should start seeing n equals 3 here. Let's look at our hotel. So if I look at our hotel, lo and behold, yes, all our second levels are full. Oh, it didn't keep my last thing. So when I put in that 11th electron, the next energy level is right here at 3s. And I'm going to start with an up spin. So 3s1. Okay? So here we go. 3s1. Now, this is going to start getting really busy. 1s2, 2s2, 2p6, and 3s1. Now, there is an easier way for me to do it than all of that. We call it noble gas notation, and we can really only start using noble gas notation after neon. So instead of writing all of this, what we're going to write instead is this. So we're going to write neon. Why is that? We're going to write neon. We're going to put the neon in brackets. So what that really shows us is we have everything that neon has. So that neon in brackets shows us that we have 1s2, 2s2, and 2p6. And then we're going to add on what we have extra. We're going to add on the 3s1. So that is going to be a shorter way to write it. So in orbital diagrams, we really don't shorten things, but for our sake here today, we are going to shorten it because these diagrams are going to be really, really messy if we don't. So I'm going to say we have everything that neon has, and then we're going to put the 3s. And we have the upspin. Okay? So that means for quantum numbers, or should we do dot first? Why is that not saving? Okay, so let's look at our dot. Oh, and it's going to do the same thing on me again. It doesn't like it when I move it right after I write. Erase. Okay, so remember our dot pictures only take our n highest number. Our highest number here is 3. We only have 1 electron here. So our picture for sodium is going to be Na with just 1 dot. That's it. Okay? That last electron we put in was in the third energy level. It was an s orbital, so 0. And there's only one orientation, and it was a positive spin. Okay? Now I want you to see if you can go and do the rest of these all the way to argon by yourself. Okay? And we will take a minute. Okay, you guys ready? Okay, so magnesium. If I look at magnesium, this gives me yet another electron. Okay? So magnesium, I've got 12 electrons. So if I'm going to take that 12th electron, let's see where it goes in the hotel. So that 12th electron is going to have to go right here. It's going to be 3s2, so 3s down spin. Okay, so let's put this here. Let's change the color a little bit. So I'm going to do notation. I'm going to do the noble gas notation. And what is happening to my screen? I'm going to do neon. So frustrating.